Hello friends, my name is Salman and you are watching my channel Solid Tech. In the last video of the CCNA series, I will discuss some important topic related to the physical component of the network, like what is the Ethernet cable, what is the twisted pair cable, what is type, and after that we discuss the fiber optic cable and wireless cable. Now in this video I will discuss some very important topics. The first topic is CSMA. Basically what it does mean, it means carrier sense multiple access with collision detection. Basically this is a diagram of a typical network. This is a old time network where we use a single wire for communicating devices with them. So in this video, as you can see, we have a central device, like all the devices are connected on my central link, which is a carrier, because it will carry the signal data from one device to another device, and all the devices are connect to this carrier device, so it is called multiple access. And collision detection means if all the devices send data and at the same time there is a collision in this topology. So for example, in my RAT devices want to send some data to another device, then it will put a 5 volt on a wire. So all the device will understand that that medium is busy and they are waiting for their queue. So in this way they can communicate with the other device, but only one device can communicate in this model. Other devices are waiting for the first device to strip off their session. So likewise, if green device want to communicate with other devices or send data to other devices, is also put a 5 volt on the wire. So all the devices understand that the medium is busy and it will wait for its queue. Now let's suppose then both the devices at the same time put the 5 volt on the medium. So what will happen? The voltage will be added up by 10 volt, and there is a collision. So all the data is lost in this topology. This topology is obsolete now, but in CCNA they are asking the question, 1-2 question from this topology. So what is collision domain? A group of network devices that will simultaneously detect a voltage spike. As I show you, okay, all the devices can listen the voltage on the from the medium or backbone. So now the next topic is duplex and speed. So what is there is a two type of data communication. One is called half duplex. In half duplex, only one device can communicate with the other device, and other device is wait until the first device finishing its communication. So one device communicated at time. The best example of half duplex is walkie-talkie. In walkie-talkie, we talk and other listen, and when other talk, we listening. So this is the model of half duplex. In full duplex, we have two devices, and two devices communicate simultaneously at a time. For example, the computer A sent to computer B data, and computer B sent data to computer A at the same time. The best example of the full duplex is telephone. In telephone, we can talk and listen at the same time. So this type of model is called full duplex. Now the modern collision domain. If we using a half duplex model, as we see in the picture, the computer is connected to the PC. When PC send some data to the switch, and switch send some data to PC. In this case, they both are collide each other, and there is a collision, and a collision is occur. So in modern collision, in full duplex there is no collision, because the duplex and in the sending and receiving occur at the same time. So in modern collision domain, in full duplex we can avoid this type of situation of collision. So as I have discussed, there are multiple type of speed in Ethernet network. For example, 10 Mbps, 100 Mbps, 1 Gbps, 10 Gbps, and 40 Gbps. The first two support the half duplex communication, but last three requires full duplex communication. The half duplex communication is required only for very old and few devices, but in nowadays we are using only full duplex network. So now the most important topic of this video is Ethernet frame, because if you understand what is Ethernet frame and how it is work, you will cover if your concept is clear, you will cover 25% of CCNA exam question, because in exam there are three main topics. One is IP addressing, the second one is packaging, and third one is frames. So in this lecture, I will try my best to explain you what is frame, how is its work. So please keep your attention on these slides. So what is frame? For example, in layer 2, if we want to communicate between two devices, we send a data from one device to another device. The data on the layer 2 is called a frame. Basically, what is frame? Whenever someone asks you what is frame, you can say the communication occur and the layer 2 layer of OSI model. This data is called a frame. So basically, we see what is the packet. The packet is a layer 3 data. So basically, the concept is very simple. If you want to send some data from one place to another, what will you do? You divide the data into a small pieces, which is called chunk, and then after dividing out, stripping out your data into a pieces, you can add additional information at the beginning of data, which is called data header. In layer 3 basically is network layer, because we are concerning at the moment is layer 2, but above layer 2 there is a layer which is called layer 3, and we call it network layer. In layer 3 we add some additional information in the beginning of the data of chunk, which we strip down into layers. So whenever we want to we add some data into a original data for additional information to the original data, we call this process is called encapsulation. So keep remember what is encapsulation. When we add additional data for communication between devices, then this type of data is called data encapsulation. So in layer 3 we add some additional information in our data. If we add information before the data, it is called an header. So in layer 3 we add IP header. IP header nothing but an IP address. I will discuss the IP header in detail in my future video. So for the time being, you know that the data is coming when the data is on layer 3, it is called a frame. It is called a packet. But when data come to the layer 2, it is called a frame. So in layer 3, data is called packet. A chunk of data with a network layer header is called packet, as I described. Now, when the packet move down to the layer 2, which I described now, this layer data is moved to a payload. What is payload? Payload, when a data move from one layer to another layer, the previous layer data is called payload. The previous data is payload for the next layer. So the data layer 3 data is treated as a payload in layer 2. So this is our payload. Now in layer 3 we also add some header information. So we on data link layer we also add some header information there. The header information is called Ethernet header, because it is working on a layer 2, and in layer 2 we call is Ethernet. And the data, now the combined data is called as frame. So a frame, a chunk of data with a data link header is called a frame. As I told you, what is a frame? Frame is a data on layer 2. We have a data with a Ethernet header is called a frame. Now we look in detail what is frame. What is the structure of Ethernet header? Ethernet header is very important. So if we look down the Ethernet header have composed of the following field. One is called destination MAC address, and other one is called source MAC address, and other one is called type, and this is the previous data, which is payload, and the final is trailer is called FCS. The ending information is called trailer, and the initial and the beginning information is called header. So what is the MAC address? So basically, what is MAC address? Every device in the world want to communicate to another device with the help of a MAC address. MAC address is basically a hexadecimal value of 12 digit. So this is the composition of the MAC address. In the first 6 digit represent the manufacturer ID, and other one is represent the serial number. So it is a 12-bit hexadecimal number. If we convert into a binary, it is a 48-bit number. So I will show you how MAC address works. For example, in my PC, I have a HP PC, and I have LAN card built-in NIC card, and every NIC card has a MAC address. So I will check and show you how to check and show which manufacturer belongs to my my LAN card, which vendor manufacture my LAN card. So for example, in this case, I will go to my command prompt by typing CMD, and I will type a simple command ipconfig/all. This command show all the network interface card full information. So as you can see, this is my Ethernet adapter, and there is a physical address. Basically, MAC address is also called a physical address, burn-in address, or MAC address. So this is the physical address. As I told you, it is a 12-digit hexadecimal number. So I will copy it and Google it. So I copy this value, and then I will move to Google and press enter. As soon as I press enter, so this is the format of the MAC address. Now I will show you the other field of the MAC address. So as I can tell you, this is the destination MAC address and this is the source MAC address. The format are the same. Now the other field is of Ethernet frame is called type. What the type will tell us? The type will tell us what type of data is in the frame. So if the frame belongs to IP version 4, that value is like this: 4400001000, 4 zeros and 4 zeros, and the equivalent hexadecimal values is equal to 0800. If we add 0x in the front of 0800, it means it belongs to hexadecimal value. So when our packet belongs to IP version 4, the type value always be the 0x0800. If we using IP version 6, the value will be the 08x86DD, and if we using the R, then the value will be changed to the 0x0806. So these are the values which describe which type of data are having in layer 2 frame. So now the last field is called FCS. FCS basically is frame check sequence. Basically this is the mechanism in which we detect any error or any bit which is missing in our data. But basically we check the consistency of our data. So for this we have a algorithm which is called CRC. CRC is a basically cyclic redundancy check. What will CRC basically an algorithm. It will act on some data which is in case our data which I receive from the layer 3, and perform a algorithm on that data, and after that it will get a value of 32-bit of CRC value. Now it will save this CRC value and send this data to the destination network. On the destination network, the data will again check with the help of CRC. The data is moved to the destination. Now again CRC algorithm is run out and give us value. And now we have two CRC values. So we check these CRC value. If they are the same, it means the data is received without any error. That's as we show here. But if the data is corrupted, the value will be changed. So in this case, we discard this data and trash out this data from the our frame, and asking the resending of the frame from the sender. So this is the video related to the packet and segments and frame of the OSI model. So in this lecture I will show you what is the data structure in layer 2, and we completely discuss the frame structure. Okay, what is how the frame is composed, what is the source address, what is the destination MAC address, what are the CRC values, and what are the type of the frame. So I will, if you like this video, please subscribe my channel and hit the like button. Thank you very much for this video.